Good evening, everyone. Am I audible?
Yes, sir.
Yes, sir.
Yeah. So today we will solve some previous year questions, the PYQs, which are based on the concept of capacitor, right? So I've collected some previous year questions for which we will see the solutions. So please keep your video switched on. Yeah. Others? Good. Others, those who are not switched on, please keep it on, or else I'll put you in the waiting room. Yes. So look at this question. The given graph shows variation of charge Q versus potential difference for two capacitors C1 and C2. Both the capacitors have the same plate separation, but the plate area of C2 is greater than that of C1. Which line A or B corresponds to C1 and why? So if you look at this question, there are two capacitors like this, which have the same distance of separation. C1 is here, C2 is here. But for the second capacitor, what is more? The area of cross section is more. So if I write the capacitance of the first capacitor, it will be epsilon naught A divided. It will be epsilon naught A divided by D, and for C2 it will be epsilon naught into A dash divided by D. So if you look at both the cases, epsilon naught by D is a constant, but C is directly proportional to the area of cross section. So which area is more? Area of the second is more compared to 1. So C2 will be greater than C1, accepted. The capacitance of the second capacitor is more compared to the first capacitor. Are you in acceptance with this? Right. So when this is the scenario, then how is this graph going to actually help us to make the decision of which line corresponds to capacitor C? For that, you need to observe the y-axis and x-axis. So y-axis is charge, x-axis is potential. So if I write y-axis divided by x-axis, it is going to give me the slope of the line. So mathematically that represents slope, whereas Q divided by V according to physics is going to be capacitance. Am I right? So if you observe, the slope of a line will be more if it makes more angle with the x-axis. So when the angle is acute, if the line makes more angle with the x-axis, that line is said to have a greater slope. So if you observe, the slope of the lines A and B corresponds to the capacitance of both the capacitors. They correspond to the capacitance of both the capacitors. Hence, what we can conclude is, since C1 is less than C2, the line which has lesser slope corresponds to the capacitor C1. So answer will be this thing. So the line B corresponds to the capacitor of capacitance C1. Am I clear with this?
Yes, sir.
So make a note of this. So just keep writing. I'll be back. Priyamvada, Adab, are you all clear?
Yes, sir.
Yes, sir.
Yes. So keep making a note of it. I'll be back. Yes. Shall I proceed?
Yes, sir.
The next question is, figure shows two identical capacitors C1 and C2, each of 2 microfarad capacitance connected to a battery of 5 volt, right? So there are two capacitors of 2 microfarad capacitance. They are connected to a battery of 5 volt. Initially, the switch S is left open and dielectric slabs of dielectric constant K is equal to 5 is inserted to completely fill the space between the plates of the capacitors. How will the charge and potential difference between the plates of the capacitors be affected after the slabs are inserted? Okay, so let's try to understand one. If you look at this diagram, right, there is a 5 volt there is a 5 volt battery which is connected to capacitor C1 and C2. So this 5 volt is continuously supplying its energy to which of the two capacitors? Is it supplying it to C1 or C2? C1, right? So the switch S being opened is not affecting what is happening to capacitor C1. Am I right? So it is the changes are taking only with respect to C2. But what I will try to understand is I'll try to find out the initial conditions. Let's assume that the switch was closed initially. Okay, then what would have been the charge on the capacitor C1? Q1 will be equal to C1 into V1. Am I right? Q1 will be equal to C1 into V1. What is the value of C1? It will be 2 into 10 power minus 6 into what is the value of V1? It is going to be 5. So answer will be 10 into 10 power minus 6 coulomb, or it is going to be 10 power minus 5 coulomb. Am I clear with this?
Yes, sir.
So had the switch been closed also, then Q2 would have been 10 power minus 5 coulomb only. Now, what is happening? Observe. Now the dielectrics are inserted. So when the dielectrics are inserted, what will happen to the charge on the first capacitor? The charge on the first capacitor will increase by a factor of dielectric constant times. So initially it had a charge of 10 power minus 5. Now after a dielectric of dielectric constant 5 is inserted, its charge will become K times initial charge, where K is the dielectric constant. So answer will be 5 into 10 power minus 5 coulomb. So it will be 5 into 10 power minus 5 coulomb. Then what about the charge on the second capacitor Q2 dash is in such a way that now the dielectric is inserted, but the battery is disconnected. Is that not the situation? Dielectric is inserted, but the battery is disconnected. So what will happen to the charge is it will remain as that was existing previously. So how much is that value? It is going to be Q2 itself, which is going to be 10 power minus 5 coulomb. So these are the changes that are going to take place with respect to the charges. Similarly, if you observe the potential, right, V1 dash will be equal to, since that capacitor is still connected to the battery, it will be equal to the initial potential difference itself, which is V1. So answer will be 5 volt. Whereas V2 dash will be equal to, since the dielectric is inserted and the battery is disconnected, it will decrease by a factor of k times. So answer will be initial potential difference of 5 divided by what is the dielectric constant of the material? It is 5. Answer will be 1 volt. So these are the changes that are going to take place for the charges and the potential difference. Am I clear with this?
Yes, sir.
Yes, sir.
Make a note of this. Shall I proceed? Yes, sir. So the next question is, net capacitance of three identical capacitors which are connected in series is 1 picofarad. What will be their net capacitance if they are connected in parallel? So if you observe, the objective of this question is, first step, you need to find what is the capacitance of those three identical capacitors. And the second thing is, if you know the value, then you need to find what will be the equivalent capacitance when they are connected in series. Okay. So whenever three identical capacitors, let's say the capacitance of each is C. Right. Whenever three capacitors of equal value are connected in series, then their capacitance will become C divided by 3. So C divided by 3 according to the question is 1 picofarad, which implies Cs is going to be equal to 3 picofarad. Here. So I'm sorry. So this implies C will be equal to 3 picofarad. So the capacitance of each capacitor is 3 picofarad. Now, when this 3 picofarad capacitor is connected across this identical capacitors in parallel, what will be the equivalent capacitance here? It is going to be 9 picofarad, because in parallel the capacitances get added up. So it is going to be 9 picofarad. Right. Now, The second part they are asking is find the ratio of energy stored in two configurations if they both are connected to the same source. So if they are connected across the same potential difference of V, then what will be the ratio of the energy stored in the two configuration? So energy stored in series is equal to half into C series into V square. So that is going to be equal to half into C series is going to be 1 into 10 power minus 12 into V square. Similarly, the energy in parallel is going to be equal to half into Cp into V square, where Cp is the equivalent capacitance in parallel connection. So this will be equal to half into, what is the equivalent capacitance in parallel? It is 9. So 9 into 10 power minus 12 into V square. So when you do US divided by UP, right, the answer will come out to be 1:9 because half and half is cancelled, 10 power minus 12 is cancelled, and V square is cancelled. So answer will be 1:9. Is that point clear? So US divided by UP will be 1/9. Shall I proceed? See, this problem I'll tell you later. Yeah. So look at this question. A network of 4 capacitors, each of capacitance 30 picofarad, is connected across a battery of 60 volt as shown in the figure. Find the net capacitance and the energy stored in each capacitor. So if you observe, C1, C2, and C3 are in series. C1, C2, and C3 are in series. And this combination of series is in parallel with C4. Is in parallel with C4. Right? Now, if you observe, for C1, C2, C3, what is going to be the equivalent capacitance? C series is equal to, or I will take it like this. 1 by Cs will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. But here all the three are identical. So which implies 1 by Cs will be equal to 3 divided by the capacitance of each, which is going to be 30 picofarad. So answer will be Cs is equal to 10 picofarad. So the capacitance will be 10 picofarad. Meaning these three can be replaced with a 10 picofarad capacitor, which is in turn connected parallel to C4. So what will be the value of C equivalent? C equivalent will be equal to Cs plus C4. So what is Cs? It is 10 picofarad plus C4 is going to be 30 picofarad. Answer will be 40 picofarad. So this is the value of C equivalent. So they asked us to find the net capacitance. So net capacitance comes out to be 40 picofarad. The next part is, what is the energy stored in each capacitor? They didn't ask for the system. They asked what is the energy stored in each capacitor. So all that we need to know to calculate the energy stored in each capacitor is, we know the formula is half CV square. We need to know the capacitance of each capacitor, and we need to know what is the potential difference across each capacitor. Right? So what is the capacitance of C1, C2, and C3? Everything is same. If you observe, for C4, it is very easy because across C4, what is the potential difference occurring? It is going to be 60 volt, because they both are connected in parallel. Whereas the same 60 volt is supposed to get divided across C1, C2, C3 because they're connected in series. So the logic here is, since these three capacitors are of same value, logically what will happen? The potential drop across each will be 60 divided by 3, which is going to be 20. So if you calculate the energy across the first capacitor, which is going to be half C1 V1 square, half into C1 is 30 picofarad, into what is V1 square? It is 20 square, which is going to be 400. So this will cancel this 200 times. So 200 into 30 is going to be 6,000. So 6 into 10 power 3 into pico is 10 power minus 12. Answer will be 6 into 10 power minus 9 joule. And the point to be noted here is, energy across the first, second, and third will be the same. So once you calculated U1, this will be the same as U2 and U3 as well. Whereas for U4, yeah. So whereas for U4, if you calculate, it will be half into C4 into V4 square. It will be half into, what is the value of C4? It is 30 into 10 power minus 12 into V4 is 60. So it is going to be 60 square is 3,600. So what will be the answer? It will be half into 108 into 10 power 3 into 10 power minus 12. So this will cancel this 64 times. Answer will be 64 into 10 power minus 9 joule. So the energy across the first, second, and third is going to be 6 into 10 power minus joule or 6 nanojoule, whereas the energy across the fourth capacitor will be 64 nanojoule. 1 minute. So it is actually 54. So it is going to be 54 nanojoule. Right? It is 54 into 10 power minus 9. Is it clear?
Yes, sir.
So make a note of this.
Sir,
Tell me.
sir, if you want, will the potential difference like divide பண்ற மாதிரி தான் வருமா equal-ஆ?
கேட்கல, புரியல.
Sir, here we are dividing 60 volts between three capacitors in series 20, 20.
As equal because the capacitance is less.
That I understand, sir. Like வந்து exam இந்த மாதிரி equal-ஆ divide பண்ற மாதிரி தான் வருமா?
வராது, அது வராம இருக்கலாம். Good that you asked that question. I was waiting for it. So divide பண்ணாத மாதிரி இருந்ததுன்னா, then what we are supposed to do is, see. Suppose in your exam, let's say this question is coming in a different way. This actually I have explained it in the class once, but Thirupi explained one time. This will be the last time that I cannot repeat it multiple times. So observe, everyone observe. Let's say this is 100 volt. Okay. So here, let's say this is a 50 microfarad capacitor. Here it is 10, 20, and 30. Suppose the question was like this. Okay. Then what will happen is across this 50 microfarad, what is the potential difference? It is 100. This 100. Whereas across the 10, 20, and 30, you cannot equally divide them. So in that scenario, what are we supposed to do? What you need to do is first find the equivalent capacitance. So step one is this. I have given steps also. Check your notes. First find the equivalent capacitance. After you find the equivalent capacitance, multiply C equivalent with the battery voltage. So what will it give you? Charge is obtained. Right? And the fourth step is with the help of charge, find the potential difference. So these are the 4 steps you need to follow. First, write this. Okay. Now see. The meaning of what I wrote here is, okay, this part I want you guys to do and tell me. What are the equivalent capacitance of these 3? Do it fast and tell me. 1 by CS is equal to 1 by 10 plus 1 by 20 plus 1 by 30. Take LCM, solve this and tell me. So basically it is 60. So you get 6 here, 3 here, 2 here. So 20 divided by 60. What will be the value of CS? It will be 3. CS is 3. So first step is what? Find the equivalent capacitance. We finished it. Second, multiply the C equivalent with the battery voltage. So you will get Q equivalent is equal to 3 multiplied with the battery voltage, that is going to be 100. So that's going to be 300 coulomb. So that's going to be 300 coulomb. Am I right?
Sir,
Ah.
sir, how did 1 by CS become 20 by 60? Sir?
So 6 plus 3 is how much? 9, 11, 60 by 11, sorry.
Yes, 60 by 11.
11 by 60. So this will be 60 by 11. So it will be 60 by 11 multiplied with 100. So it is 6000 divided by 11. Am I right? So 6000 by 11 coulomb is going to be the total charge supplied by the battery. But what happens here is 6000 by 11 is present across each capacitor that is participating in the series combination. Now, I know the capacitance, I know the charge, then how do I find the potential? We know that Q is equal to CV, so V will be Q by C. 10 divided by 6000 by 11. Here it will be 20 divided by 6000 by 11. Here it will be 30 divided by 6000 by 11. Did you understand?
Yes, sir.
Yes, Sai Kalyan, are you clear?
Yes, sir.
So if you add all the three values and see. I wrote these values here. This value, this value, and this value. If you add all the three and see, you will get 100.
Okay, sir.
But only thing is, the units nammakku. So 110 plus 220 plus 330. Actually, I think I made a mistake. Wait. This is potential, this capacitance. Sorry. 6000 by 11 into 10 power. Try to understand, right? It's charge divided by potential. So it is a reciprocal. I'm sorry. So Q by C is what is the potential. I hope I'm clear. Am I?
Yes, sir.
Yeah.
So what's the final potential difference?
That you have to calculate and see. See, here it is 6000 by 110. Here it is 6000 by 220.
Yes, sir.
And here it is 6000 by 330. So what you can do is 6000 by 110. If you take it out, you will get 1 by 1 plus 1 by 2 plus 1 by 3. So 6000 by 110 into, if you take LCM, you get 6 plus 3 plus 2, the whole divided by 6 itself. So this thing is 11. 11 will cancel this 10 times. 1 0 is gone. 6 and where is the 100? You will get it. That is how it works. Purida? Clear or not? I need a confirmation.
Yes, sir.
Okay.
Yes, sir.
I'm not able to speak much. Okay. So maybe I can do 2 more problems. After this, I give you the sheet. You guys can work on this. Okay. Let's see the next problem. There is a parallel plate capacitor of capacitance C, which is charged to a potential V. So there is a parallel plate capacitor. There is a parallel plate capacitor of capacitance C charged across a potential difference V. Okay. It is then connected to another uncharged capacitor having the same capacitance. Now this is removed and connected to another uncharged capacitor, right, of the same capacitance. So if the capacitance of this is C, it has already been charged to potential difference V, whereas the other capacitor is of capacitance C, but it is not charged at all. So what is going to be the charge here? Q will be equal to CV. What will be the charge here? Q will be 0 initial. This will be the initial condition, right? Now, what is that we need to find is, find the ratio of the energy stored in the combined system to the energy stored initially in the single capacitor. So if I take this to be U final and U initial, according to the question, we are supposed to find what is the value of U final by U initial. Read the question carefully. Don't make the mistake of taking UI by UF. Okay. Now, if you see what is the value of UI, it is very simple. If you see what is the value of UI, it is very simple. It is half CV square. Whereas for me to find U final, I need to find out what is the potential energy across the first capacitor and what is the potential energy across the second capacitor. If you observe this problem, it is based on the concept of redistribution of charge. It is based on the concept of redistribution of charge. Meaning, when the charged capacitor is connected across the uncharged capacitor, then there is a redistribution of charge taking place till a point where the potential of the first capacitor and the potential of the second capacitor becomes the same. Okay. Okay. So if you observe, for me to calculate U final is going to be equal to U1 plus U2. Now the question is, when will the redistribution of charge going to stop? When the common potential is attained, and we know the expression for common potential. So common potential is given as C1 V1 plus C2 V2, the whole divided by C1 plus C2. What is C1 V1? C1 V1 is CV. What is C2 V2? It is 0 divided by C1 plus C2 is 2C. So if you observe, the common potential obviously is going to be V by 2. Now, what will be U final? So U1 is going to be half into the capacitance of the first capacitor C into the new potential, which is going to be V by 2. And here also it has become V by 2. That is the common potential attained, right? So half into C into the new potential that is obtained, half into C into V square by 4. Plus, what about the second potential, energy? It is half into C into V square by 4. So what is going to be the value of U final? It will be CV square divided by 4. It is CV square divided by 4. So U final divided by U initial is equal to CV square by 4, the whole divided by CV square by 2. CV square by 4 divided by CV square by 2. So CV square and CV square will get cancelled. 2 will cancel this 4 2 times. So the answer will come out to be 1 by 2. So the meaning of this is whenever you have a capacitor which is charged and it is connected across an uncharged capacitor, the initial energy will always decrease by 50%. Will always decrease by 50%. So one thing you need to be careful is U final by U initial is 1 by 2, whereas U initial divided by U final is going to be 2. So you need to be very careful. In this question, they asked U final by U initial only. Find the ratio of the energy stored in the combined system to the initial single capacitor. Right. So this is what you need to report. Suppose the same question comes in MCQ, right? Next time you can remember. You need not sit and solve the whole process. You can remember whenever this kind of a problem is there, U final by U initial is half and U initial by U final is 2. Okay. You can make a note of this.
So I guess we have already solved this question, sir.
We did. We solved it already. It is a part. We solved it from your study material book. Okay. We'll do one last problem. See, there are 3 identical capacitors, C1, C2, and C3, each of capacitance 6 microfarad. And they are connected to a 12-volt battery as shown. The first thing that we need to find is find the charge on each capacitor. Second is find the equivalent capacitance of the network. Third is find the energy stored in the network of capacitors. Okay, the first part. So for us to find the charge on each capacitor, all that we need to do is first understand what is the potential difference across each capacitor, because the formula for charge says Q is equal to CV. So all that we need is all that we need is the capacitance and the potential difference across that capacitor. Right. So if I look at Q3, it is easy. So Q3 is equal to C3 into V3. So C3 is how much? 6 into 10 power minus 6 into what is the value of V3? It is 12. So it is going to be 72 into 10 power minus 6 coulomb. So that is going to be the charge which is appearing across the third capacitor. Whereas if you look at C1 and C2, right, they both are in series and fortunately they both are identical. Right. So the total potential that is appearing across C1 and C2 is 12. The total potential that is appearing across C1 and C2 is 12. Since they are identical, the 12 will get split as 6 and 6. Right. Then what is going to be the value of Q1? Q1 will be C1 into V1. C1 is 6 into 10 power minus 6 into what is the value of V1? It is going to be 6 volt. So answer will be 36 into 10 power minus 6 coulomb or 36 microcoulomb. And a point to be noted is this value is exactly the same which is appearing across C2 as well. Right. So that is going to be the charge on each capacitor. The second point is find the equivalent capacitance of the network. If we observe, we are clearly able to say that C1 and C2 are in series. So for series, we will apply 1 by CS is equal to 1 by C1 plus 1 by C2. So that implies 1 by CS will be equal to 1 by 6 plus 1 by 6, which is going to be equal to 2 by 6. So CS will be equal to 3 microfarad. So let this be 1. Meaning these two can be replaced with a 3 microfarad capacitor. Now this 3 microfarad is connected across C3 in parallel. So C equivalent will be equal to CS plus C3. So what is the value of CS? It is going to be 3 microfarad plus what is the value of C3? C3 is going to be 6 microfarad. So the total value is going to be 9 microfarad. It is going to be 9 microfarad. That is the equivalent capacitance of this network. Okay. And the last part of the question is, what is the energy stored in the network of capacitors? Meaning, what is the energy stored across the whole network? They are not asking across individual ones. Okay. So the energy stored in the system, if I calculate the energy stored in the system, that will be equal to half into C equivalent into V square. So that is going to be half into 9 into 10 power minus 6 because C equivalent is 9 microfarad. 9 into 10 power minus 6 into V square is 144. So this will cancel this 72 times. So when you multiply 72 with 9, you get 648 into 10 power minus 6 joule, or it is 648 microjoule. So this is going to be the total energy that is appearing across the network. Okay, you need to read the question very carefully. Here they told energy stored across the network. Instead, had they asked the energy stored across individual capacitor, then all that you need is you need the capacitance of the device and you need the potential difference across this device. We already know the potential difference across all 6, 6, and here it is 12. So you can directly apply the formula and see. So for first one, it will be half C1 V1 square. For second one, it will be half C2 V2 square. Third one will be half C3 V3 square. So if you calculate the individual values and then add them together, you should get the same value of 648 into 10 power minus 6. That is another important point to be noted. Okay. So am I clear with this?
Yes, sir.
So make a note of this. Okay. Is it clear?
Yes, sir.
So that is all for today. And yeah, we'll wind up. So I'll share the sheet. The remaining problems you guys can write.
Yeah, Saturday.
Any other questions?
No, sir.
So do you have
I'm not able to answer.
Saturday? So do you have test on Saturday?
No, no test. No test. So you'll have the test only after the holidays. So with this, we are closing. Right? You have 2 weeks of
So
time.
the 29th.
Yes. 29th, you have test.
Sir,
Yeah, tell me.
the question for physics is the first 2 chapters.
Yes, first 2 chapters, and it's 80 marks, not 40 marks.
Okay, sir.
80 marks, and you need to sit for 3 hours. Right?
Okay, sir, and for maths, every chapter speed till now,
So every chapter that has been taught.
including the differentiation also.
The differentiation, maybe I'll test till the parametric.
Okay, sir.
Double differentiation alone will be eliminated. That also I'll tell you if at all, see, because double differentiation is simple only. Okay. So if I have to include, I'll include that also, because you need to differentiate it twice. That's all you need. Okay. I'll let you know. I'll let you know. Okay. So there are no questions. We can wind up.
Thank you, sir.
Thank you, sir.
Yep.
Thank you, sir.
Thank you.